Hello, my little mathematicians. Today, we're going to explore writing equations from both tables and graphs. First of all, a lot of times the directions will say, when you write an equation, please express y in terms of x. That means they want it to be y equals something x. Like, what are you doing to the x to get y? That's what I want you to be thinking in your head. What do you do to x in order to get y? And remember, I just said, it's usually almost always going to start y equals something that you're doing to x. So let's go ahead and look here. What are you doing to x in order to get to y? If it's getting bigger, then you're either adding or multiplying. So let's try adding first. 2 plus what gives you 9? 7. Now, does that pattern hold up? Well, 3 plus 7 is 10. 4 plus 7 is 11. 5 plus 7 is 12, and 6 plus 7 is 13. So that pattern held up for the whole table. So we always took x and added 7, which means that's my equation for problem 1. For problem 2, okay, again, from x to y, they're getting bigger, so you're adding or multiplying. Well, I could go 1 times 4 to get 4, but 2 times 4 is not 5. So let's try adding instead. 1 plus 3 is 4, and 2 plus 3 is 5. 3 plus 3 is 6. 4 plus 3 is 7. 5 plus 3 is 8. So each time you took the x and you added 3, and that gave you the y. So your equation would be y equals x plus 3. And that's what they mean when they say, please write it or express it, express y in terms of x. So in terms of x, what are you doing to x to get y? Remember, if you're getting bigger, you're either adding or multiplying. And if from x to y is getting smaller, you're subtracting or dividing. And that whatever pattern you see, it has to hold up for the whole table. Because you could go, oh, it's getting smaller. 2 times 0 is 0. Yes, that's true. But is 4 times 0 2? No, it's not. So then what we want to do is we want to see, okay, so since they're getting smaller, let's try subtracting. 2 minus 2 is 0. 4 minus 2 is 2. 6 minus 2 is 4. 8 minus 2 is 6. And 10 minus 2 is 8. So to get y, we always took x and subtracted 2. If you want to, remember, you can always pause the video, try it yourself, and then unpause it and check yourself. Okay, they're getting smaller again, so I'm going to try subtracting first. How do I go from 10 to 2? Well, if I subtracted 8, does that pattern hold up? 11 minus 8 is 3. 12 minus 8 is 4. 13 minus 8 is 5. And 14 minus 8 is 6. That pattern was true for the whole table, so I can say that the equation is y equals x, whatever x is, minus 8. That will give you y. Okay, for our next one, number 5. Again, they are getting bigger. From x to y, you could go plus 9, but 4 plus 9 is not 16. So let's try multiplying. 3 times 4 is 12. 4 times 4 is 16. 5 times 4 is 20. Okay, so let's see if these hold up. 6 times 4 is 24. 7 times 4 is 28. So since all of those worked with taking whatever x was and multiplying it by 4, we can say that this is my equation. Y will always be 4 times x. Remember, we want to put our variable behind our coefficient, okay? So we don't want it to say x4, we want it to say 4x. And what I mean by that, yes, technically that is true. That is saying the same thing, but we prefer this way. All right, problem 6. 0 to 0 is kind of hard to tell what's happening, so let's look at the next one. Can I see the pattern? 1 plus 8 is 9, but 2 plus 8 is not this. So let's try multiplying. 1 times 9 is 9. Let's see if times 9 works for the whole table. Well, 2 times 9 is 18. 3 times 9 is 27. 4 times 9 is 36. And even 0 times 9 is still 0, because anything times 0 is 0. So the pattern holds that you take x and you multiply it by 9 in order to give you y. Okay, let's go ahead and take a look at our next one. The next one says from 6 to 1. Well, 6 minus 5 is 1, but 12 minus 5 is not this. So let's try dividing instead. If I go 6 divided by 6, that gives me 1. So let's see if that pattern holds up. 6 divided by 6 is 1. 12 divided by 6 is 2. 18 divided by 6 is 3. 24 divided by 6 is 4. And 30 divided by 6 is 5. So I always took the x and divided it by 6. Okay, for my next one, well, actually, before I move on, I want to show you that this is saying the same thing as this, x divided by 6. And actually, it's saying the same thing as this as well. Y equals 1/6 x. And you're like, how does that work? Well, think about it. You have 1/6 times x, right? Put x over 1. 1 times x is x. 6 times 1 is 6. So you have x over 6, which is exactly what this is, x divided by 6. So multiplying by 1/6 is the same thing as dividing by 6. Just in case it's multiple choice and it doesn't match what you wrote down, these are all saying the same thing. All right, for our next one. Again, if you haven't tried any yourself, why don't you try? Okay, so now that you unpaused and you're back with us, they're getting smaller. You could try subtracting 8, but that pattern doesn't hold up. 20 minus 8 isn't 4. So I could instead divide by 5, and that pattern holds up for the entire table. Because if I go 10 divided by 5, I get 2. 20 divided by 5 is 4. 30 divided by 5 is 6. 40 divided by 5 is 8. 50 divided by 5 is 10. So I'm always taking the x and dividing by 5. And that's saying the same thing as x divided by 5. Or that new way, how is a fraction? It would be multiplying by 1/5, right? So multiplying by 1/5 is the same thing as dividing by 5. Just as we explored in the problem 7 up above. Okay, why don't you go ahead and if you haven't tried, like you try these ones. So pause the video, try them. Now you unpause the video and you're checking with us. They're getting bigger, so let's try adding. 5 plus 3 is 8. Let's see if that pattern holds up. And yes, it does, because 6 plus 3 is 9, 7 plus 3 is 10, 8 plus 3 is 11, and 9 plus 3 is 12. So my equation would be take whatever x is and add 3. That will give me my y. For the next one that you tried, they were getting bigger too. So if you try adding, well, 4 plus 8 is 12, but 6 plus 8 is not 18. So let's try multiplying instead. 4 times 3 is 12. 6 times 3 is 18. 8 times 3 is 24. 10 times 3 is 30. And 12 times 3 is 36. So each time we multiplied our x by 3, and then that gave me the equation. Before I move on, I want to show you a nifty trick. This nifty trick only works for multiplying or dividing, but you can find the number that's multiplied in front of the x if you do this really nifty thing. Are you ready? Okay, so the number that's being multiplied in front of x, you could do the change in y over the change in x. So from here to here, 12 from 16 changed by 4, right? And 3 to 1 or 3 to 4 changed by 1. So if you put the change in y over the change in x, it tells you what to multiply the x by. Well, that was 4 over 1. So we multiplied the x by 4. That works here too. From 9 to 18, you added 9. From 1 to 2, you added 1. So the change in y over the change in x was 9. And hey, that's what we multiplied by. Even for dividing, the change in y from 2 to 3 went up by 1. And the change in x from 12 to 18, it went up by 6. So that's 1 over 6 that you would be multiplying with the x. Well, multiplying by 1/6 is the same as dividing by 6. Isn't that a nifty trick? Technically, it works with these guys too. It's what you're multiplying the x by. So right here, this went up by 1, this went up by 1. So you have 1 over 1 or just 1. So you multiplied the x by 1. But just something to think about later if you're like, okay, I know that I'm supposed to multiply the x by something, but I can't figure out what it is. And yes, these were easier, but sometimes it might be like you're multiplying by 1.5 or 3 1/3. If it's something tricky like that, you know it's being multiplied, you just can't figure out by what. Use this trick of change in y. How did from here to here change, and how did from here to here change? And put the change in y over the change in x, and that will tell you what to multiply your x by. It's known as the rate that you multiply the x by. Just something to think about if you find yourself with a hard one that you can't just figure out easily like we did. All right, now we're going to move on, and we're going to learn how to write an equation from a graph. Okay, well, the first thing you want to do is you want to fill in the table. So right here, these are tables with points from your graph right here. Find a pattern. So think to yourself, what did you do to x to get to y? Just like we did on the other page. Once you have your table, then you look for your pattern. And once you figure out what the pattern is, you can make the equation. Okay. And they just want to always say that, like, you know, these are linear equations. So we're going to connect the points on the graph to make a straight line. So right here, if you were to draw or connect all these points, see how they make a straight line. And that's just letting you know that all of our equations are going to be linear.